Well, welcome everybody. To those of you who've been stalwart and attended all of these this week, that's great. And I'm Leslie Furno from Central Hall Commons. I think this is our last event now for Earth Week. And we've had a really an excellent week, I think, in discussing some of the topics around the Maine Climate Plan. This has been a collaboration between Central Hall Commons and the Piscataquis County Democrat Outreach and Education Committee. And we've really, I think, learned a lot about what's available in our region and how the plan could be implemented and what needs to happen. So it's been great. Before we start, I just want to again recognize that we are on land occupied for millennia by the Wabanaki people, and to honor the current tribes, the Penobscot, Passamaquoddy, Micmac, and Maliseet tribes, and to remark that they believe that they belong to the land rather than the land belonging to them. And so we are grateful for the use of the land and for their efforts to preserve and protect land, air, water, and we hope in this process to promote cultural healing. I'm going to just turn this over to Gloria, who will introduce Scott, our speaker, and will introduce the topic.
Thank you, Leslie. Strategy B in Maine's Climate Action Plan is to modernize Maine's buildings. A couple of goals listed under this section are to advance the design and promote climate-friendly building products, including mass timber and wood fiber insulation, and to encourage innovative wood material manufacturing facilities to locate in Maine. Promoting innovative wood products will reduce greenhouse emissions while supporting economic development in Maine's forest products sector. GoLab is mentioned in Maine's action plan on page 50 if you're curious and you want to look it up. And we're happy to have the Chief Marketing Officer for GoLab, Scott Dion, with us today. Scott has been working in the lumber and building materials industry since he was 16. He started at a local lumber yard and hardware store, working his way through high school, which was Caribou, and college, Dartmouth College. Scott was employed as a territory sales representative for a Brockway Smith company, where he built relationships across the Northeast. He returned to retail in 2007 as an executive level manager, helping grow S.W. Collins to 8 profit centers. Scott left his role as vice president of operations with S.W. Collins in July 2020 to help carve a path for GoLab to access the mainstream residential marketing construction market. Now it's my pleasure to introduce to you Scott Dion from GoLab.
Gloria, thanks very much. Really appreciate that introduction, and thank you all for the invitation today. Really happy to be giving this presentation, and I'll take questions as they come up, but I'll actually be leveraging a slide deck that hopefully will be answering a lot of questions, so it might make sense to wait to the end. But either way, I'm fine with answering questions as we go through. So just a little bit, Gloria offered that background. What's interesting about me is I'm certainly a product of the Maine lumber industry. My father worked at Columbia Forest Products for 4 decades in Presque Isle, so that's a veneer plywood mill. And I grew up, first working on a farm and then working in the lumber and building materials industry. So that's over 2 decades of experience with lumber and building materials, but also with Maine's forest products industry. And as an aside, when I went to Dartmouth, my focus there was environmental science. So I spent a lot of time looking at issues around global climate change. And also because of my construction background and my engineering, my desires to learn more about engineering and buildings, we were often looking at operational energy of buildings as a way of trying to address climate issues by reducing that operational energy. And we'll kind of talk about how wood fiber insulation fits into that. that theme throughout the presentation here. So just a little bit about GoLab. I'll talk a little bit about how it got started as I go through the presentation, but our production facility is going to be located in Madison, Maine, in the former UPM paper mill. And we we own that paper mill at this point in time. We're bringing in the equipment to start manufacturing 3 lines of insulation, and our product line will be on the market in 2022. So I think I'll just share screen, dive into the presentation, cover wood fiber insulation, because it's one of these products that if you don't have any experience with wood fiber insulation, it seems like it's too good to be true. Because, you know, a lot of products made out of wood, the biggest concern is water and fire and rot and so forth. So I think it's just important for me to talk about the context of the project and then the product specific, so that everybody has a good handle on what we're doing here and what our mission truly is moving forward. So TimberHP is the brand of our insulation product line. GoLab is the parent company, GoLab Inc. And our key tagline when we enter the market is insulate better, live better, which it's deliberately broad because we're targeting several different audiences with our product line, because it does have so many levels of resonance. So hopefully everybody's seeing my screen okay, and I'm going to move this to the middle. We're going to be
and thank you.
Okay, great. We're going to be producing 3 product lines in Madison. Blown in loose fill insulation, which is a replacement for cellulose insulation and loose fiberglass for attic spaces and dense packing in cavities. A bat insulation, which is similar to what people are familiar with, the pink stuff, or maybe it's mineral wool that gets installed in stud cavities and walls and in ceilings and floors. And then we have an exterior board product, which is very, very unique. And I'm eager to show you just a little bit of video on the board here in a few moments, but it's very counterintuitive when you start looking at it. So, and to the left here, just we have a lot of virtue icons that we try to leverage to highlight the features of wood fiber insulation, and we'll go through those as we navigate the presentation. So wood fiber insulation, it's new to North America, but it's been around for over 25 years in Europe. And this technology is a proven technology. We'll talk about the big key players and manufacturers in Europe and the growth that's taking place in that market and why it's taking place here in just a little bit. When you're thinking about wood fiber insulation, you know, you got to think about the residential market in North America. Over 90% of the houses in residential buildings that we erect are framed with wood and sheathed with wood. And what we're trying to show the market is that we can insulate with wood also, so that we're not creating these hybrid wall assemblies that have tremendously high carbon footprints, are composed of materials that are non-recyclable, composed of materials that off gas and cause issues with indoor air quality or releasing greenhouse gases. So we have a very unique story to tell. And wood, once you get past, as I said, water and fire, people really start appreciating the merits of wood fiber insulation, which it's really that third bullet: windproof, waterproof, and breathable. That's the definition of Gore-Tex, and that's really the definition of how wood fiber insulation works. So we'll work into the performance aspects of the product in just a bit. But I think just starting out, looking at the insulation market in general and why wood fiber insulation is so crucial, so pivotal in our approaches to really mitigate the effects of global climate change and the releasing of greenhouse gases. So nearly all of the insulation products on the market today are either made from or heavily dependent on fossil fuels. And wood fiber insulation is a very low energy production process of creating that product. When you start looking at carbon footprints of insulation, all of them have tremendous carbon footprints. If you think about what insulation is made to do, it's made to, drive down the operational energy needed to heat and cool our buildings. So in other words, it's really intended to be a product that reduces the amount of fossil fuels we use to heat and cool our buildings. But all of the popular insulation products that are on the market today need a tremendous amount of fossil fuels for production. So this slide just shows that wood fiber insulation arrives at the job site carbon negative. So all of the popular products that are listed here, fiberglass, mineral wool, spray foam, and XPS would be blue board or pink board foam. All of those products, it takes about 8 to 10 years to offset the carbon footprints of those products through their operational savings when installed in a building. So you talk about trying to address greenhouse gas emissions by increasing the amount of insulation in our buildings. Well, there's a lag time if we use all these traditional products. That lag time's 8 to 10 years. So we're actually, the more we insulate today, the worse we're making global climate change or the issues around global climate change, because we're increasing the amount of emissions going into the atmosphere. We don't really see the savings for 8 to 10 years. Whereas with wood fiber insulation, we see the savings immediately upon installation in buildings. We're sequestering carbon in those buildings, and we're getting the operational savings because wood fiber insulation is wind tight, offers tremendous R value. So this slide just shows, carbon sequestration. The more wood we can put in our buildings, the more trees that we can grow. And again, sustainability is a key factor in looking at tree growth. We want to have sustainable forest growth. So we're actually trapping more carbon with the buildings that we're building with wood and insulating with wood. So for wood fiber insulation production, it requires very low energy, but it's embedding that carbon into the built environment. So that's why we're carbon negative out of the gate. So I usually don't lead with the environmental aspect. I'll circle back to it at the end. Typically, I'm doing presentations to folks in the lumber and building materials industry, and we'll talk about what they're looking for because the product has to perform. And we have layers of performance that we talk about within the industry. So I typically don't lead with the environmental aspect with the industry, just simply because they want to know that the product's going to perform first, and then the environmental aspects are secondary to them. Whereas for some audiences, the environmental aspect is obviously right front and center. So a little bit about the project and the team. GoLab was founded by Josh Henry and Matt O'Malia. Josh Henry is a physical chemistry professor from the University of Maine. He quit his job 5 years ago and partnered with Matt, who is a passive house architect, to really launch wood fiber insulation domestic production in North America. And it's been very much a marathon to try to bring this technology to the States. They were importing wood fiber insulation from Europe and using it on their projects. But obviously shipping makes it very difficult and adds to the carbon footprint of just trying to get this product here, even though there's so many merits of the product that we'll talk about that are worth paying more and importing. So, and then just the rest of our team, there's obviously me, Bill Ginn, who's started Nature Vest for the Nature Conservancy. Bill has been very instrumental in helping us launch our project. And Ken Friedley, our CFO, he's been extremely instrumental in helping us get the project off the ground. So the reason why wood fiber insulation makes so much sense in Maine and really a lot of these underserved wood baskets across the country is we're really not taking we don't have enough uses for low value fiber. I mean, in the state of Maine, we've lost, 5 or 6 paper mills over the past 5 years, and a lot of that low value fiber, so residuals from lumber production, the chips that are left over from lumber production, or the low value trees that have to be removed from stands in order to go back and replant, that fiber really doesn't have much of a home in the state of Maine anymore with the loss of the paper industry. And that same story resonates across the entire country and certainly up into Canada also. But you look at the Pacific Northwest, they've lost numerous paper mills also. And they tend not to remove a lot of the low value fiber from the forests. They leave it in the forest because there is no value added manufacturing that will make it make financial sense for them. And obviously that low value fiber rests in the forest, becomes tinder, and they have tremendous issues with wildfires across the Pacific Northwest all the way down into California, which all of you are very, very well aware of. So in the state of Maine, we are actually 30% below replacement rate on forest harvesting at a sustainable level. So being able to go in and remove more low value fiber so that we can have healthier stands that can sequester additional carbon as those larger trees grow is a tremendous merit that we could take advantage of here. As far as the production of our product, we're taking, as I said, those chips from lumber production, and the custom chips that are made for pulping, which we don't have, a lot of need for that these days. And we run them through a refining process, and we add adhesive, and we create the 3 lines of insulation. So it's all softwood species agnostic. So we can use spruce, pine, fir, hemlock, a little bit of cedar, but really it's the size of the tree doesn't matter to us. It has to be a clean chip. We can't use any bark, but it can be just twigs for that matter. And again, if we have any waste that on a construction site or in our manufacturing process, we could take all of the scraps of our product and just put them back into the production cycle and make new product. And this is our manufacturing facility, the former UPM paper mill. It's in all about 600,000 square feet. The newer portion of the mill is about 200,000 square feet, and it was built in 1981. And this production facility was shuttered simply because the market for super calendar paper dissolved. There was really no use for that paper. So this production facility was going to sit vacant. People had bought the paper equipment on the inside and were removing it. We came along in 2018 looking for a production, a building to house production. And we were actually able to hire on 3 of the senior operational managers for this facility to make sure that when all of the paper equipment was being removed, that none of the infrastructure was being harmed. So the electrical infrastructure, fire suppression, heating, cooling, and so forth was not going to be harmed. This is located right on the Kennebec, and we have a behind the meter contract for hydroelectric for this facility. So very, very unique opportunity for us, and we got extremely, extremely lucky with our timing to get this facility. So out of Madison, we're intending to serve primarily the Northeast United States and into Atlantic Canada with insulation. We have plans for additional facilities across the US and other underserved wood baskets that could use value add production for low cost fiber, so that again, we can take a more sustainable approach to forest management and be able to add value to that low value fiber stream. So on wood fiber insulation, and this is more of my forte, talking about the background of the project is great, but really Josh and Matt do an amazing job, the founders, talking about it. For me, I'm about the product and the opportunity for the construction industry and how that impact, there's so many layers of impact around bringing wood fiber insulation production to North America. It's tremendous. So These are the large producers of wood fiber insulation in Europe. Steico is the largest producer, Gutex is the second. So in all, right at this point in time, there's 15 production facilities in Europe creating the same products that we're going to be manufacturing in Madison, Maine. And the European market is oversold. So it's about a $700 million market today. There's 4 to 5 new production facilities that were announced just this year because the European market is so oversold on wood fiber insulation. That'll make it $1 billion insulation product line for the European market. And that's pretty tremendous, seeing as in Europe, most of the construction is masonry, and wood fiber insulation really only works in wood frame construction. So 25% of the residential market in Europe is wood frame construction. The other 75% is masonry. You look at wood frame construction in the States, we're well over 90% on the residential front. So the opportunity to use wood fiber insulation is so much larger than what it is in Europe. The issue with all of this production in Europe is they don't even want to really look at the North American market because of issues around shipping. About $10 million of insulation gets imported to North America per year, but it's extremely expensive. You put $5,000 of insulation in a container and you spend $5,000 in shipping to get that insulation to North America. So wood fiber insulation right now is used on very few projects where cost really isn't a big driver. The other issue is in Europe, their wood costs are 3 times what the wood costs are in the United States. I mean, right now in the construction industry, you look at OSB, plywood, and lumber, all that stuff, all those products are through the roof, 3 times what the market really has been in the past. But we're not using that high value wood. We're using all of the leftover. So all those wood chips, which really have no place in the market because of, the dying paper industry. And also those low value chips don't follow the highs and lows of a commodity market. So they're extremely inexpensive. Those same chips in Europe are 3 times the price consistently across the board. And energy is twice the cost in Europe. So this product is really in the European market. It's sold as a premium product, higher cost, focused primarily on sustainability. And that's really what's driving the growth of this product is more wood frame construction, because again, they're very conscious of what's happening with global climate change. They want to use more mass timber, more wood frame construction, and the insulation that makes perfect sense to complement that is wood fiber. So that's really what's driving this at this point in time, is a sustainability mission in Europe, because it is a cost premium. For us, when we transpose the production to the US, because of our very inexpensive wood fiber and our very reasonable rates of energy, we don't have to sell this product line as a premium. It comes in cost competitive with all of the mainstream insulation products on the market today. So the loose fill insulation is priced per pound the same as cellulose insulation, which essentially is recycled newsprint. Our board product will be the same price per board foot to foam, exterior foam insulation that you're familiar with, either the white, the blue, the pink, the green, and significantly less than mineral wool. And our bat product will be right in that sweet spot between fiberglass and mineral wool. And we can talk a little bit about the merits of all of these 3 products as we work our way through the presentation. So again, for our mission at Go Lab and TimberHP is not just to focus in on being insulation manufacturers. Our mission truly is to take this proven technology that exists in Europe and is extremely successful in Europe and translate that technology to the North American market and really be the resource and the stewards bringing wood fiber insulation to mainstream construction, and be the educational resource primarily to show how this product meets and exceeds building code and energy code, while also putting our forests back to work, while also creating a product that's recyclable, environmentally sustainable, carbon sequestering, and a product that we can insulate and not have to wear the fibers on our skin for the next week after we insulate, or worry about what we're breathing in, because all of our products are over 90% wood. So for me, again, when I came up with the brand TimberHP, the HP has, multiple layers of meaning, multiple layers of impact. For me, when I present to the construction industry, I have to lead with performance, because as I said, if the product doesn't work as well or better than the mainstream products on the market, even if it's the same price, nobody's going to buy it. So the ability to actually harness the impact to the environment or harness the impact to human health, we don't have that opportunity because the product just doesn't work. Fortunately, we have over 2 decades of experience with this product in Europe that shows that the product does absolutely work. So high performance first for the construction industry, and then we talk about healthy planet and healthy people in creating healthy indoor habitats. So a little bit more on the product line. The loose fill product, if you look at the primary competitor, would be loose fiberglass and loose cellulose, which can be installed in attic spaces or dense packed with blowers in wall cavities and floors, and even in rafter assemblies on roofs. Wood fiber insulation has a home in the market because cellulose, we're using less and less paper. So cellulose insulation is derived from newsprint, and they can't really incorporate office paper or other types of paper into production because it leads to performance issues of the insulation. There are some manufacturers out there today who are trying to incorporate cardboard into cellulose manufacturing. But again, it causes issues with settling. The fiber doesn't have enough body to hold up over time. It settles and creates air gaps. Whereas with wood fiber insulation, you have this clean fiber stream, and the size and shape of the fiber prevent it from settling tremendously over time. So it's a long-term solution, long-term insulation solution. We create this product simply by taking wood chips, refining and steaming, and we add borate, and the borate addresses fire, it addresses mold and mildew, and it addresses insects. We've tested European product with Underwriters Laboratory in the States, and we were able to get a Class A flame spread, and I'll show you what that means in just a moment with a video. But when we introduce the borate, we do it in a wet phase, so we completely encapsulate the fiber, so we don't have to worry about any humidity getting into the assembly and leaching off those fire retardants over time. So it's a long-term safe solution that has no issues with settling. And you talk about low dust and no toxins. They do their best with cellulose to make sure that that they're not introducing a lot of outside debris and materials to the product line, but still you get plastics that are in there, and you of course have the printing ink that goes into the newspaper, and that's all being embedded in walls and can lead to some issues. And when they introduce the flame retardant, whether it's borate or ammonium sulfate to cellulose, it's put on in a dry process. So when it's installed, a lot of that dry powder comes off, and people are breathing that in. And because it's installed as a dry or added as a dry product, over time that indoor humidity can actually leach it off and cause issues with long-term fire prevention. That same fiber we use to produce our bat insulation to fit in wall cavities and roof cavities. We blend it with a polyester fiber and we bake it in an oven to create bats. And this is the same exact process that Rockwool uses to create their insulation, except instead of using softwood fiber, they're using steel slag and basalt, and they need a coal burning power plant to power their production because they have to melt all this, all these materials down. And again, you start thinking about it, okay, Rockwool has grown in popularity in the United States. It's been around in Europe for 80 years, but we're insulating our buildings now with stone. And we have to start questioning, does that make sense? It's high performing. We don't have to worry about it burning or issues with water. It has decent R value. But the more and more we insulate with stone, we're insulating with a material that has high thermal conductivity. So the warmer it is outside, it transfers that heat into the built environment and has an opportunity to drive up cooling loads, which has been seen actually from partners that we have in the Pacific Northwest. When you start talking about encapsulating buildings with stone insulation, they have more and more 100-degree days, obviously directly related to climate change. And they're talking about, yeah, we're addressing our R-value needs in the cooler times, but now that we're insulating with stone, our cooling loads are going up because of these issues with thermal conductivity. With wood fiber, it's very low, has very low thermal conductivity. If it's hot outside, that heat comes after the built environment. The wood fiber stores that heat, radiates it back out when it's cooler in the evening. And then the same thing goes for when we're heating in the wintertime. I live in a log home. That's actually where I'm talking today, is a coped log home. And you get the logs warm during the day, and then in the evening, that heat will radiate back in. The same thing happens with wood fiber insulation. You're essentially creating an all wood assembly that can hold the heat that we're producing inside of our houses and radiate that heat back in as evening gets cooler. So we talked about the loose fill and the batt product all being made from the same borate treated fiber. So this is a European batt, which is made very much to our specifications by Styco, and I'm just taking a torch to it to show that it doesn't burn. And we tested the loose fill product and the batt product with UL and received a Class A flame spread and smoke spread on the product. And again, when you start looking at fiberglass, when exposed to flame, fiberglass will melt. When you look at mineral wool will hold back the flame. But again, there's some additional liabilities associated with insulating with mineral wool. Our board product, this exterior board product, has a little bit of a different production stream. We're not adding flame retardants out of the gate. 95% of the board product that gets produced in the European market has no flame retardant in it because it's intended to replace foam insulation, which, foam is derived from petroleum and it can ignite. So with foam products, they actually have to introduce flame retardants. With the board product, to outperform foam, it doesn't need any fire retardants. But we do have plans to offer a board product with a flat fire retardant. But we've tested this product with ICC NTA and got a Class B flame spread without any flame retardant. So all this product is softwood fiber, PMDI adhesive, which is about 4%, and that would be like Gorilla Glue, and then 1% paraffin. So the big virtue of exterior board insulation made out of wood fiber, is it doesn't trap moisture in the built environment. Today, and code is driving this, more and more buildings are having to put continuous insulation on the outside to deal with thermal bridging. And if we're always using foam, so white, pink, blue, green, that foam, if there's indoor humidity that's trying to exit the built environment, it'll get beyond the studs and maybe the sheathing, but then it'll be trapped against the sheathing because of the foam and can't exit and can cause issues with, mold and mildew growth, rot. And again, we talk about it as being vapor open. Wood fiber insulation is vapor open. It allows the structure to breathe. It's wind tight, so we don't have a lot of air movement, but at the same time, it's allowing that indoor humidity to exit the built environment instead of being trapped in assemblies and causing issues with allergens related to the mold and mildew growth and causing issues with rot and resilience of our structures. So this product is hydrophobic, so that means bulk moisture that hits it, it'll repel it, but the humidity, the vapor, it allows that moisture to exit the assembly. And I have a video to show that. So this is just a water board that I built at the Madison Mill. And here I'm just exposing water to the wood fiber board product. And you can see that the water just beads up and sheds off the surface. And typically this board is being used in wall applications, but it can be used in roof applications too. And during construction, the European market will actually allow the board to stay exposed anywhere from 3 to 6 months and be exposed to bulk moisture without any degradation. And the same with UV because of the manufacturing process. So the board product is somewhat prevalent in North America on some higher end projects. That's primarily the product that makes somewhat financial sense to import, but it's still twice the price of what it's going to cost us to produce it. This project is College of the Atlantic out on Mount Desert Island that's just getting finished up now. This is all wood frame construction, and they installed 5.5 inches of wood fiber insulation produced by Gutex in Europe on this project. And I love showing these temporary steps because those are the big questions we get about wood fiber board insulation is, you know, if it gets exposed to water over time, it's not going to be durable. It's just going to expand and deteriorate. And this, you know, these steps actually sat on the job site on the ground for months, people walking in and out of this building. And as you can see, there's really no degradation. So it's a very stable and a very resilient product. And as far as flame goes, again, I took the torch to some foam. You know, a lot of times we might see a little bit of EPS foam still out there on buildings, and you know, all these foam products have flame retardants in them to prevent the propagation of flame. Or we might see XPS like the pink or the blue, and you take flame to those products that we're wrapping around our buildings, and this is, you know, what happens. They melt, they off-gas terrible chemicals. So I mean, even if we do have a fire, you know, the fire department doesn't want to be going into those buildings where there's a lot of foam. If they're insulated, the wall cavities inside of the structure with foam, the same thing. All that off-gassing, they can't even get close to the fire. So this box I built is wood fiber insulation that has no flame retardant in it at all. It's just soft wood fiber, PMDI, and paraffin. And as you can see, it repels that flame. It carbonizes the surface of the box, and the flame just will eventually, you know, go away. And Edith, who is the director of media and design for Go Lab, she actually came up with our logo and does a tremendous amount of work for us. Extremely talented person. She's the one removing the box there just to show what the little house looks like. And again, you know, that's the fire aspect of foam. The big liability is wrapping wood structures with foam and trapping that indoor humidity or any type of moisture against wood framed assemblies. So again, high performance, healthy people, healthy planet, and we can kind of work down through those topics, and then I'll save time for some questions. We talked about high performance, not trapping that moisture in the wall assemblies. We allow that indoor humidity to escape so we don't have issues with mold and mildew. As we insulate better, as we build tighter houses, issues with indoor humidity are becoming a tremendous liability. And we want to start insulating with vapor open insulations that allow that indoor humidity to enter the assembly and then dry back to the inside of the structure or work its way out of the structure. Again, remaining airtight but vapor open. Very unique thing about wood fiber insulation too that a lot of people don't know is that wood fiber can actually get wet and not lose R value. It can hold up to 15% of its weight in moisture and not lose R value, which is pretty tremendous. And it just, you know, doesn't have issues with losing its shape on the board product, as we saw with those steps. Again, just talking about performance and low thermal conductivity, the more we insulate with stone, the issues with transferring heat in to assemblies is becoming an issue. Whereas with wood fiber, that thermal storage, it'll hold the heat and then radiate it back out when it's cool. And with healthy people, I can't stress enough that we're insulating with clean wood chips that are refined. I mean, this is Edith showing us the loose fill product. All that is wood fiber with just a little bit of borate for flame, mold, and mildew inhibition. And that's what we're insulating with. There's no toxins. So you don't have to worry if you're an installer what you're breathing in, getting those itchy, scratchy fibers in your skin. You don't have to worry about that with wood fiber. And just, thinking about long-term off-gassing or any issues to that effect, you don't have those liabilities to worry about with those, indoor habitats. So for us, it's, creating healthy indoor spaces by having vapor open assemblies and allowing that indoor humidity to exit, not causing issues with allergens, but also not putting anything toxic in the built environment that's going to cause issues down the road with off-gassing. And acoustics, wood fiber insulation performs acoustically better than just about any insulation on the market. And you think about how much time we spend inside these days and how crucial it is to have a safe space that's quiet. So healthy indoor air quality, but also a quiet space so you don't have all the noise from the outside or within the built environment. Being able to use wood fiber insulation on the interior walls to hold back noise from rooms around the house. On most of these projects that we see on multifamily, so multifamily units that are getting built, they're using 3 times the amount of acoustic insulation on these projects compared to thermal insulation. So again, a tremendous opportunity to sequester carbon by using more and more wood insulation instead of stone or fiberglass or foam. And the Healthy Planet piece, really, we're very fortunate in the state of Maine to have a lot of stewards of our forest products in general, but also the forests that we grow. I mean, so many of our forests are being grown sustainably because people care about what's happening in their backyards. So we're going to be in a position out of the gate to be able to have FSC certified product for the market. And that really matters, because if we're talking about sequestering carbon, we got to make sure that if we're taking those trees, turning it into insulation, putting it in our buildings, that we're in turn growing more trees to sequester more carbon. And that's what I had on the presentation. I'll stop share, but I can go back to the slides at any time, but I'll just open it up for any questions if there's questions out there.
I was going to ask about the flame retardant, but you've already pretty well gone over that. I have a question about how the exterior boards are adhered. I mean, are they screwed
That's
in?
a great question. Well, if you think about the foam that we put on the outside of our buildings, we're using a lot of times safety cap nails or maybe a roofing nail, but primarily safety cap nails. And we can do that because foam has good compressive strength. A lot of people are starting to use mineral wool on the outside of buildings because they want it to be vapor open. They don't want to trap that moisture with the foam like we talked about. So they're putting the mineral wool on the outside of the building. The issue with mineral wool is it's extremely squishy. So they have to use screws and plates, and they can't over tighten it. Otherwise it causes issues with installing the siding and it's all wavy. With our product, it has decent compressive strength. So we're doing product videos right now using European product. I install the 1.5 inch product, which is code compliant R5, with a framing nailer. So I nail it on with a framing nail through the sheathing into the stud, and it's all tongue and groove, so they stack on one another. But you could just use a nail. You can use a safety cap nail. You could use a screw if you want, but it would be pretty slow. I just foresee in applications where it's 1.5 inch code compliant for mainstream construction, they're going to use a pneumatic nailer. When you get into using those thicker masses like you see on the College of the Atlantic, the 5 inch, our board line will produce wood fiber board 1 inch all the way to 10 inch, monolithic, all one layer. And you can use that on roof assemblies. In those applications, you use screws, and there are screws that are engineered out of the European market that'll hold the wood fiber insulation and hold the siding that gets mounted to the wood fiber insulation using a batten rain screen or strapping. So hopefully that answered it for you.
Yeah, thank you.
You're welcome.
Bill?
Yes, Bill.
Oh, I have so many questions. First of all, when is it available?
So with our production, we're going to have the loose fill product available the second quarter of 2022. And then the bat and the board product are going to be available the fourth quarter of 2022.
Wait.
Yeah, we had a year delay because of COVID. I mean, our financing really got, halted to some extent because people just were concerned about what was going to happen. And now everybody's like, we wish we were producing insulation, because all of these mainstream insulation products that are on the market are on allocation. You can't even get most insulations these days. So people are very, very eager to get wood fiber and have other solutions. So.
Well, it seems to me that this goes far beyond insulation uses. And, I was wondering if it can be molded or machined or maybe 3D manufactured. It seems like so many possibilities to replace foam. I know in so many applications, people use foam core materials for signs, for exhibits, for artwork, all kinds of things like that. Have you thought about those other kinds of applications?
Yeah, so you're spot on. If you look at the European market and wood fiber insulation and products, it's being used in a lot of different applications. They actually have wood fiber board that has stucco applied, and that's your insulation and your siding all in one. We're not going to enter the market in that way, but we do understand there's a tremendous opportunity for other manufacturing to leverage wood fiber insulation. So surfboards, for example, we get that inquiry a lot because people are looking for a more sustainable solution to making surfboards and flotation and things of that nature. And you'd mentioned 3D printing. The project that they have at the University of Maine that they're going to be 3D printing a house, it essentially creates a honeycomb structure out of cellulose. And, there's a binder in there. And they're talking about insulating those assemblies with wood fiber loose fill, blowing it through and dense packing it. Josh Henry, our co-founder, who's the materials chemist, is also working with the University of Maine to patent a wood fiber foam that can be used. They're actually showing it used in like a Yeti cooler. So the contents of the cooler itself made out of a wood fiber foam, but that piece, they actually are going to have IP in place around that. Coming up with a wood fiber foam really just changes it. Changes, so much of manufacturing that's leveraging foam these days. And we can really have so many more products where we're sequestering carbon instead of creating issues with carbon by having all these foam products.
A couple other questions. I'm going to have to watch your video again, but when we remodeled this house that we're in now, it was using contemporary techniques of 2001 and 2 fiber insulation in 6-inch studs, then covered with plastic on the inside, foam on the outside, cedar siding. I wonder, and also the interior walls are all standard, rock wall or whatever you want to call it.
Yeah, sure.
Sheetrock. So does your product, could that be used for interior walls as well?
Yeah, absolutely right. It's really a drop-in replacement for any of the cavity insulations that are out there on the market. And you really look at what the building code is driving. So that 6 mil poly that's on the inside of your house is really trying to deal with vapor management, indoor humidity, not getting into the wall assembly, condensing, turning to water, and causing issues with mold and mildew. The issue is with 6 mil poly, you have to be absolutely meticulous and make sure that you don't have any penetrations or issues, because even a small hole can feed so much moisture into that assembly, and then it won't have a chance to dry back out. And now you think about that, if that moisture gets into that wall assembly and then there's foam on the outside of it, it has really nowhere to go. It can't dry outside because the foam traps it. It has to try to dry inside, but then it's hitting that 6 mil poly, and it has to try to find a hole to dry back in, which is not going to happen. So the building code today wants you to have an interior vapor management membrane, and it's 6 mil poly a lot of times because there's a lack of exterior continuous insulation. The more exterior continuous insulation, the less crucial it is to have a vapor management membrane on the inside, because you're keeping the sheathing and the studs warm. But at the same time, so you can use painted gypsum, for example, painted drywall instead of using 6 mil poly. The code will allow you to do that. The issue is you're always relying, if you're putting lots of exterior insulation, so in our neck of the woods, you'd really have to have at least 3 inches of foam on the outside of a building. And how many people are going to want to put 3 inches of foam on the outside of the building, because it leads to issues with installing your siding and window and door build outs and all those things, but also just trapping that moisture. You're expecting all of the moisture that makes it into the wall to dry back into the inside of the building, which does not always happen. So that's why it's better to have a vapor open exterior insulation, so it has a chance to dry out or dry back in. And if you, I'm not a huge fan of large masses of exterior continuous insulation for just any project. You know, I look at, you know, being from northern Maine, from Aroostook County, we're in climate zone 7. We've always used continuous insulation, exterior foam or whatnot. The issues become, we have these beautiful old homes that were built 100 years ago. They were sheathed in with boards. And the way that we're going to add our value to the structure is we're going to tear all the siding off because it's old wood siding, and we're going to put some foam board on it. We'll probably put a new house wrap. We'll put some foam board on it, and then we'll put some vinyl siding. But we didn't do anything to the inside. So we didn't deal with any of that interior vapor management, all that vapor that's going to get into the wall cavity. That house is going to heat a lot easier with the exterior, with the house wrap, because it's a nice air seal. With the foam, it's going to heat easily. But the issue is all that moisture now that used to just exit that house through the wood siding and through the boards is now being trapped, and you're going to have issues with rotting out all those old boards in no time. I mean, what's probably helping your house, typically when you're installing wood siding these days, if you're creating a really tight envelope, you put a rain screen. So any moisture that is getting behind the siding from the outside or working its way out will actually exit the assembly through this rain screen and not attack the siding and have issues with rot or issues with paint or stain sticking. A lot of times people will go through and they'll do a meticulous job on an old home where they'll sand all the clapboards, or maybe they'll sand and treat some of the shingle siding, and then they'll finish it with a stain. Only next year they go and look at it and they're like, wow, the stain's failing. Well, it's not really the stain that could be failing. It could be all that interior vapor that's actually working its way out, causing that stain or that paint to come off the wood siding. So interior humidity vapor management's a huge deal when it comes to resilience in the built environment.
One of the things about the Maine climate plan, which I'm sure you're very familiar with, is that we have a situation where we are trying to now re-insulate, weatherize a lot of old homes in Maine. Yeah. We've got, you know, over 500,000 homes that are built prior to 1960. And those homes over time need weatherization is key to energy saving. And so I'm wondering, we talked about this the other day on we had a program on weatherization, and we talked about exterior weatherization, because it's very expensive and time consuming to go into people's homes, tear down walls and weatherize from the inside. And blown insulation in walls is really not adequate. It's fine for ceilings and attics, but it really isn't, I think, a very satisfying solution. Maybe you have a different position with the wood fiber insulation. If it's blown into the walls, maybe it works better, but with studs and all the, things that go in between, it sometimes is difficult to fill those spaces. So I'm wondering, we talked a little bit about possibility of exterior insulation applied to the exterior of buildings in kind of a mass format. In other words, saying to homeowners, here, we've got this product, we can come and we can put this on the outside of your home. We don't have to disrupt your home. We don't have to tear it apart. We don't have to do anything. Is that something that is doable with this? Or do we have to take off siding first and then put it on? Or can you put it on over siding? Or how does that work?
Yeah, it's being done in Europe right now. So I'll come back to the weatherization piece as how I see it taking place, but about creating these panels, NYSERDA, so New York State, is actually putting a lot of money and research into using energy sproing, which is a Dutch approach where they actually have these wood fiber panels that have cladding already on them. They come in outside of the house and they just lag these panels right onto the outside of the structure. It's got brand new siding on it. Can have windows and doors, popped out or just set in, but they're panels. They could be cross-laminated timber, wood fiber insulation, and then your siding all on there. And all they come in one day, lag them all onto the building. They can even do roof assemblies directly right on top of the roof, and then just move on to the next structure. So New York State's investing a tremendous amount of money in looking at that opportunity, because it is, if you look at the existing structures we have in America right now, if we just insulated all of the existing structures that need insulation with wood fiber insulation, think about how much carbon we would be sequestering in the built environment. We would be, I think, really addressing our CO2 emissions by just installing insulation. And insulation is so accessible to everybody. Anybody can buy a bag of insulation and insulate their house. Not everybody can go buy a photovoltaic cell and put it on their roof. So the panelization piece, it is happening. I could send you a link to what's happening with NYSERDA. I can send you a link to the Dutch company that does this already. But the way I see it going is we still need to do on these weatherization projects, these retrofits. I think we need to do cavity insulation. The issues right now is if we're going to do dense packing from the outside in a cavity with an insulation blower, we have cellulose and we have fiberglass. Dense packing fiberglass is a tricky business, especially in a remodeling type situation. Dense packing with cellulose has been done for years. The issue is you have to get to 3.5 pounds per cubic foot in order to achieve that. So that's high density. With wood fiber insulation, you don't need to even get to that density. Because of the shape and size of the fiber, you put less weight into the wall assembly and get the same R value as cellulose. So on that cost slide that I showed, we were talking about our product being the same price point as all borate cellulose per pound, but really for coverage, we're less because there's over 20% greater coverage in wood fiber insulation than cellulose. And we don't have to worry about it settling over time. And that's the issue with cellulose is the fiber has no body. So though we're dense packing it, 2 years later, after that starts settling, you have more air gaps that exist. With wood fiber, you don't have that issue. And the only other point I'll make is, really with cellulose, the CAP agencies all moved to borate treated a few years back, and which is great because the issue with flame retardants other than borate, so ammonium sulfate, for example, you install that into a wall cavity, and the CAP agencies used to do that, either a blend or all ammonium sulfate. And then you get that indoor humidity entering that insulation. The insulation gets moist, and then you have a urine smell because of the ammonia. So we're steering clear of that. And with our product, borate we use half as much borate to achieve the same flame spread as cellulose. So we can actually make sure that we stay at a really good cost price point because we don't have this really expensive, additive that we're putting in there for flame. The issue that cellulose is facing is they're spending more and more money on paper, and they have to use a tremendous amount of borate because they're putting it on in the dry phase. For us, our raw material costs are significantly less than what they're paying for dry fiber, and we're just using half as much borate. So long term, we're going to have a loose fill product that's really going to be price competitive going into the future. I think when we start talking about putting continuous insulation on the outside of old structures, we have to have vapor open options. And foam is a terrible option, because if we're only talking about retrofitting, as I was mentioning to Bill, and we're not addressing interior vapor management at all, and we're putting all this foam on the outside of these old buildings, and we still have that indoor humidity entering the cavity, it's going to get trapped and it's going to start rotting out that building that's been standing for 30, 40, 50 plus years, because we made it too tight with the foam. So we either go to mineral wool and then deal with the squishiness and deal with the thermal conductivity that comes with it, or we go to wood fiber insulation, and that is vapor open and it can allow that vapor to make its way out. But it's also vapor managing. You know, as I said, if wood fiber gets wet, I mean, say somebody does a poor flashing detail around a door or a window, and the wood fiber insulation gets saturated in a corner time and time again. You don't have to worry about failure there, because wood fiber insulation functions just like a tree. That capillary action, it spreads that moisture out through its entire surface. So though it gets saturated at one point, it'll spread that moisture out through its entire surface through capillary action. That moisture will exit the insulation when temperature, pressure, and humidity allow. So it's very vapor managing. And that's really how I like to describe wood fiber. It knows how to manage moisture.
Thank you.
You're welcome.
Bill?
Yeah, this is so exciting. I remember many years ago when I was living in Maryland, there was a company that would build new homes and retrofit older homes with, if I recall right, a stucco covered foam material, and they would shape the materials, and it looked quite nice. I was very impressive, but I suspect that, you know, there was a lot of problems not too long after installation. As you mentioned earlier, foam just doesn't hold up against, you know, the elements and abuse. The other thing is that as this product comes online and you start using it for new construction and old construction, it sounds like you might have to do some training, maybe new job opportunities for people going into the trades.
Yeah, so much of our marketing approach and marketing budget is focused just on education, and it's overcoming, you know, the hurdles of perception when you start talking about wood fiber insulation. And, you know, what we foresee is more and more panelization taking place for construction. So manufactured, not just houses in a production environment, in a factory environment. So we would call those modular, right? Modular type houses, but also just structural assemblies. So walls and floors and roof assemblies. So more and more production that takes place in that factory with wood, because right now you look at a lot of what's taking place is they're having a wood structural panel that has foam, that has mineral wool, that has fiberglass, all of these products getting added. So there's tremendous liability with the workforce, but also recycling. How do you recycle this monster that you're creating and all this waste? You've got wood, you've got all these things where if you start talking about all wood construction, you're building these all wood panels that you can then ship out to a site. So cross-laminated timber, wood fiber insulation, a rain screen, siding, all installed, brings to a site. You drop these wall sections in place, put the roof on. You're building a house. You're building a structure in a week that, you know, would really take out in the elements, could take months. So more and more panelization is going to be taking place. More and more prefabrication is going to be taking place, and wood fiber is a great product to complement all that. So more and more all wood construction and design. And that's what's happening in Europe. I mean, that has been happening for the past 20 years, but that is growing. And as we talk to more people across the US, we see it happening more and more and more. And they're so excited when they start talking about cross-laminated timber and wood fiber, because right now they're going cross-laminated timber and mineral wool, cross-laminated timber, EPS foam, and then they put them on CNC machines, cut out these blanks, and then they have this hybrid mess that they can't recycle. So they're filling up the dumpster, sending it to the landfill. They just want to say, okay, if I put wood fiber insulation, I have these cutouts of CLT. Can you guys take them back on your next truck, grind them up and throw them back into your production? Yeah, no problem. We can chip it, throw it right back into production, so we don't have all this waste making it to the landfill. So it'll be tremendous. But again, you're 100% right on the education front. When we enter the Northeast market, it is going to be a slow ramp, and that's really what we figure. It's going to be about 3 years before we get to a point where we could say we're at near full capacity. But hopefully by then we have a West Coast facility coming online and really bookend that country and start, supplying more and more people across the country with products so that we can take advantage of these new technologies.
I hate to say it, but we don't have all those years, Scott. Carol.
It amazes me that we don't have a wood fiber insulation
Yeah.
production facility in North America.
Yeah.
I
Carol?
did want to ask Scott, if you think that in order to accommodate the switch from fossil fuel fiberglass and other types of insulation to accommodate wood fiber insulation, is it going to require like changes in building codes? Do they favor one over the other right now, or is it open?
That is a good question about code. What code cares about is performance, but also life safety. So for us, we just have to make sure that our product is tested on the life safety front. So that would be fire and smoke. And then on the performance front, make sure that we're tested and we have an evaluation report that allows us to drop right into the building code. With the loose fill product, the code is already set up, the standards are already set up because it's a cellulosic fiber. So we have the same testing that takes place with cellulose, so that's no big issue. With the bat product, it's very similar to other bat insulations that are out there. We just have to make sure that we meet the fire. I mean, it's vapor open, it has good R value. The board product, we have to do a little bit additional testing there because that board product is really something new to the market, and making sure that we're meeting all of the standards that are out there for the construction industry will be important. So with adding flame retardant for residential construction, we don't need to do that. But on commercial, because we think there is going to be an opportunity to use more and more wood fiber board product on commercial applications, we are going to have to add a little bit of flame retardant. So we are working with third-party testing laboratories who will be doing our testing for us as soon as the product comes off the line. We've been doing R&D testing with these same laboratories with the European products, so they know what to expect. We know what to expect, and they're kind of leading us in the right direction for testing that'll fit the US and Canada. All these products, because they've been around for 2 decades, have been tested extensively in Europe to be shown to perform, but we can't really use that data. So it all has to be tested here domestically. And we're up for that challenge. We know that it's going to be a costly endeavor, but that's part of our working capital is to make sure that we're fully tested. Yeah.
Great, thank you.
Bill?
You mentioned standards. I wondered if you'd worked with the National Institute of Standards and Technology Fire Research Lab, and if you've used your products or thought about using your products in other things like furniture.
Yeah. So on the testing piece, we've been using ICC, NTA, and Underwriters Laboratory, just simply because in the construction industry, those are the 2 most recognized independent laboratories. There are others out there that we could work with. We will be doing some additional fire testing on assemblies with multiple layers of wood fiber insulation here shortly, but again, those are costly. It's interesting that you bring up furniture. So with wood fiber insulation, medium density fiberboard, you'll know goes into furniture all the time, like IKEA furniture. It's kind of like particle board. With our product, it's more of a lower density board product, because you have to have that low density in order to achieve the R value. It's all a dry process. As an aside, there is wet process board wood fiber insulation produced in the States, and that technology has been around for decades. A lot of times it's, black, used in re-roof applications, and rubber goes on it. But that wet process board, it's quite a bit denser, so it has less R value. With our product, it's not quite dense enough to be structural, so it wouldn't necessarily be good for a lot of other structural elements like furniture. But where I think it would be interesting to look at is, automotive industry, certainly in shipping containers, things of that nature, being able to use that product there. But I think for furniture, they're going to want something a little bit denser than the low density fiberboard that we have.
Scott, I have a question about the forest, and a couple of questions. One is about whether your company owns forest, or whether you're leasing it, or whether you're just using independent landowners. And the other question is related to the climate and related to concerns about pest and the health of the forest. And obviously with the climate crisis upon us, we're already seeing some pests migrating north. And so I wondered how that factors into your future planning.
Yeah, oh, that's great, actually. We're not going to have a chipping operation on site out of the gate. It may be 5 or 10 years down the road, perhaps, but we're aligned with wood products manufacturers who have residuals. So lumber producers that have these leftover waste materials that they'll just ship to us, and we'll turn into, and again, a Maine-based company. All of our wood's coming right from Maine. And then custom chip manufacturers who can produce those chips for us using that low value fiber that they have to pull out of the woods anyway. I mean, of course, as you guys know, when you go in and you cut a stand of trees, you have your saw logs that can go into lumber, but you have to remove all of these small trees and all of this debris that has to get chipped and go somewhere. It can go to, boilers and be burned, or the paper industry if they have a need, but that'll be coming to us. So we really, if you look at all these pests coming our way, so say we have an influx of really terrible wood, it's just, starting to rot, it has, infestation, any issues like that, we can take those products, just small chunks of wood, and have it chipped and turned into product that we can in turn use. So the fiber really can be very poor fiber. It just has to be clean, and it can't have any bark on it. And really, it's softwood. We could make wood fiber insulation out of hardwood, but then we would have to probably add additional chemicals to soften that fiber, and that's what we're trying to avoid, is just use softwood. And there's such an abundance, and I foresee that issue is all of this, as we start dealing with more and more pests coming through, we're going to have trees that we can't use for anything. They're going to be chipped, and what are we going to do with them? Leave them in the forest and then turn them into tinder? Well, if they can be chipped and sent to us, wonderful. We can make it into insulation.
Thank you. I have one other question. I know this is going to sound funny, but do you need investors?
We are actually closing our seed round this month. We've been very, very fortunate after the first of the year. During COVID, not too many people are stepping up to the plate, but I think we have a little bit of room left in our seed round. In our Series A round, we have a little bit of room there to finish our financing. We're actually completing the financing of our production facility by leveraging an $85 million bond. That's a tax exempt bond. That is really the reason we're able to do this is because it falls under recycling and reuse, because that's what we're doing. So we're able to leverage this tax exempt bond, which is a 30-year bond for $85 million. We have to ante up $35 million of equity. So on the Series A front, there is a little bit of a gap there, but we have a lot of folks who are coming on board. So the short answer is yes. If you're interested, just reach out to me and I can talk to you more about the investment side. We have a financial team, Bill Ginn, who is wonderful, and Ken Friedley, our CFO, are, they're the ones who really are the horsepower behind that. But it's such an interesting project because if it had not been for COVID, we would have closed the financing of this production facility using a new market tax credit, but we would have only had 2 production lines, loose fill and bat, and we would have been waiting to bring the board on later as we ramped up and had some cash flow. So, because of COVID, we had to pivot and go to this bond, but it's tremendous because now we're able to do all 3 lines, and that's really what we need to do. I mean, it's great. It's great to be drop-in replacements, but we want to have that whole comprehensive above-grade solution so that we can meet the cavity, the continuous exterior insulation, the attic blanket applications. We'll have everything you need from the ground up for insulation, acoustic on the inside, all from wood fiber insulation.
Thank you.
You're welcome.
Are there other questions? Hi, Bill. Yeah.
I just want to thank Scott for being here. Great presentation, exciting thing that you're doing, and appreciate you being here today.
Yeah, thank you so much for the invitation.
Yeah, it was really a wonderful presentation and something that I didn't really know anything about. So I was very glad to hear it. Thank you so much.
No, you're welcome. And my email is really easy. It's just scott@golab.us. So if anybody has any questions, just email me and I'll get right back to you. If there's any interest in learning more about the project, I have a separate slide deck I can send out also.
Great.
Thank you so much.
Yeah.
Thank you, Scott. So interesting. Thank you.
Scott, there's and I also want to thank the county Dems for helping with this project or spearheading it. It's been really great working with all of you, and let's do this some more.